Good evening, everyone. A warm welcome to all the participants to day 6, the final day of our faculty development program. It's my pleasure to introduce our esteemed resource person for today, Dr. J. Alfred Daniel. Dr. Daniel is an assistant professor at Karpagam Academy of Higher Education, Coimbatore. He holds BTech in Information Technology and MBA in Software Enterprise Management from Anna University and Masters in Computer Engineering from Yunpuk National University, Korea. Dr. Daniel has published over 40 international journals and conference papers in the areas of vehicular networks, IoT, and big data analytics. He is the author of an Elsevier book on intelligent vehicular communications and holds a Korean patent on cooperative cognitive intelligence for Internet of Vehicles. He has received multiple awards, including the Best Paper Award at ICSNS 2015 and ACM Travel Grants for ACM SAC 2014. His research interests include vehicular networks, intelligent transportation systems, cooperative cognitive intelligence, as well as augmented and virtual reality. We are truly honored to have him with us today to share his valuable insights. Now, I take great pleasure in handing over the session to Dr. J. Alfred Daniel, sir, to lead us through this enlightening and informative session. Over to Daniel, sir.
Yes, right. So I'm extremely honored to be a part of this faculty development program. So my topic of discussion today is data science application and case study. So we are going to see from insight to impact, how a data is transferred into a feasible application. Right. So this is the agenda of today's topic. So first I'm going to introduce data science with respect to application, and we'll see why data science matters with relevant to application perspective. So all the agenda will be based on application and case studies. Right? And the third topic will be the domain of data science, and we'll see a few applications which I've categorized into six applications, which will be healthcare, education, industry 4.0. So like that, we have around six applications I've categorized. So next, we'll see use cases. So these are the four use cases which I'm going to discuss in elaborately. The first one is Parkinson detection using voice data. Next one, Netflix recommendation engine. GE Aviation predictive maintenance. The final one, emotional adaptive virtual reality theory. This project we are working on as of now. And finally, I'll end up with emergency trends and key takeaway. So this is the agenda of today's discussion. As I already told you, first we'll see data science in terms of application perspective. So these three are the integral components. First one is statistics. Next one is machine learning. The third one is domain expert. So what is statistics? That is important, which is the foundation of understanding data. So for understanding the data or information, a clear framework is required, that is statistics. So next comes the machine learning, so which is the engine of automation and predictions, where it powers your automation and predictive analytics. Next comes the domain experts. That is important. The understanding of problem domain is very, very important to build a data science framework. So being in healthcare or finance or agriculture or education, so domain expertise is very, very important. So what will be the impact? So the impact will be drives evidence-based decision making in every domain. So these three components are integral: statistics, machine learning, and domain expert. Fine. So why data science matters? So these are important. We are aware the significance of data in today's progression. Fine. So data is a new decision maker. We are aware that tons and petabytes amount of data which is being generated every single seconds. As this example shows, a single autonomous car generates 40,000 GP per data each day, where its cameras, LiDAR, GPS, radar, it produces 100 minimal 100 kbs of data per second. So this is the amount of data which we are working on as of now. Fine. So why data matters? So data is a new decision maker. We are aware that now in today's world, data speaks. So it is a new decision makers. It turns chaos into clarity. It powers innovation. It shapes future. So how it happens? So how it is converted? How the information or else how the data is converted into a feasible application. So that is important. That we'll see in detail in our current slides. Fine. So these are the domains which I already told you, the application domains. The healthcare, which is important, the data that saves lives. Next comes the education, the data which drives decisions. So knowledge is empowered through education. So that's why data that drives decision. So next, industry 4.0. So that is an integral part where data powers innovation. So next, finance, data that drives decision making with respect to finance. And agriculture, the data that drives every field, agriculture fields. The final one, which is very, very important in today's aspect, because we are talking in terms of climate change, so social and environmental impact. So data for betterment of planet. Right? So these are the six important application where which we are going to see in detail. Right? So I just want to end up with this quote: "Data science connects idea, industries, and intelligence." Right. So as I already told you, so we are going to see. I've categorized to simplify. I've categorized into six categories. So first one, healthcare. So I already told you this data that saves life. Fine. So first one, predictive disease before predicting disease before symptom appears. So diagnosis. So next, you're analyzing X-rays, MRIs using deep learning. So next, personalized medicine tailored to your DNA. So these are some of the important applications, feasible applications, which is related to healthcare. Fine. So this is one of the important use case which I got from a Stanford University literature that A detects breast cancer 5 years earlier than doctor in Stanford. So this is a proven use case where the Stanford University has trained a model with more than 1 lakh mammogram images, and they have come up with a feasible framework that detects breast cancer 5 years earlier than doctors in a doctors. So that is a thing, and they've also reduced the false negative by 10%. They've used CNN model, and the ultimate aspect is that it predicts the cancer before it appears. That is an integral part. Right? So the impact. So it converts a treatment to prevention, where data science saves times, money, and lives. So this is integral part with respect to healthcare. So next comes your finance. So the data that guards wealth. So these are the three important applications. The first one, fraud detection using anomaly detection model. Next one, credit score and customer risk profiling. Third one, algorithmic trading with predictive analytics. Yes, the trading part plays an important role where we use predictive analytics to predict the progress or to which trade you have to opt for. So these are the three important applications relevant to finance. So as I already told you, we have a use case related to that. So in real time, the Mastercard's AI engine analyze over 2 lakhs transaction per second, detecting anomaly in real time. So this data is from Mastercard Cyber Intelligence Report 2023. So AI plays a significant role in real-time fraud detection. The bank uses AI to flag the suspicious transaction within a second. So this is the comparison chart which I've put it here, where AI prediction time is minimal compared to human. So this particular data is from Mastercard Cyber Intelligence Report 2023. Right. So what is the impact? So the impact would protect millions of dollars every day and make a global finance more secure. So that is an ultimate objective where data that guards our wealth. Next comes education. So data that shapes mind. Right. So this is the analytics from an abroad university where predicting students dropout risk using performance analytics. And so they have predicted students dropout using performance analytics, and they came up with some kind of model. So in the upcoming years, the student retention was 20 percentage higher through this performance analytics. Fine. So that is important aspect. This is from a abroad university. So next is adaptive learning system powered by AI. So which we are well aware that applications such as Coursera, Udemy, so all these are powered by AI. So which is an integral part for adaptive learning systems. And third one is important, the curriculum design based on learning patterns. So that is important. So based on students' learning pattern, the curriculum is designed as per their knowledge level, as per their understanding aspects. So that is AI plays a predominant role in that kind of aspect. And as I already told you, AI system improves students. This statistics is from UNESCO 2023. AI system improves students' retention by 20% through personalized supports. Fine. So as this diagram represents, 20 percentage of high retention is through AA boost student retention, and 25 percentage better performance. Students using AA performs better, and 15 percentage fewer dropouts. AA reduce students dropout. So those are statistics from UNESCO. So AA enables personalized attention and data-driven students. Fine. So what is the impact? So it turns teaching into a personalized experience for every learner. So this is how an education where data that shapes each individual minds. So next comes your industry 4.0. So data that powers mission. So we are in industry 4.0 era where the manufacturing, the IoTs, the digital twins, the computer vision, all these play a major role in today's industry, or specifically industry 4.0. Right? As I have already mentioned here, smart manufacturing with IoT and predictive maintenance, that is important. Like IoT is an integral part of today's industrial aspect, where everything is automated, where AI or a machine learning will be the backbone for IoT framework, where all the automations are taken care by AL and ML. So that is important. So IoT is a very predominant aspect related to Industry 4.0. So smart manufacturing with IoT, where data science plays a key role for predictive maintenance. So next comes the digital twins that stimulates real world missions. Fine. As I already mentioned here, there is a VR headset where a VR headset can simulate a real world mission where a pilot can stimulate a real world aeroplane through VR framework. Fine. So VR application, the application is very high. For example, if you want to have a power station, a virtual power station can be designed through Blender and Unity framework, where you can use VR for training the members or training the staff members, and also they can have a complete awareness of the machineries which are available. That is important. So digital twins, where it combines the VR framework combines with data science to produce a simulated real world mission. So that is important. So I'm just talking in terms of VR plus data science. So that will be our future, the upcoming. So next, third point, the quality control using computer vision. So that is a predominant, this application plays a major role. So where the computer vision is uh, a backbone of today's industry 4.0, because it drives all the innovation through the computer vision. Right? So where the data science plays a major role. Right. So next is the case study, which is pretty interesting, where we are aware of GE Aviation, which uses AI to predict engine failures before they happen, saving millions. Fine. So the GE Aviation, they have trained a deep learning model on 15 million flight records, and they've achieved 97% of accuracy detecting issues earlier, and they have saved around 300 million annually in maintenance costs. So this is how data science play a significant role in industry 4.0. So this is one aspect, and the application scenario is larger in terms of industrial aspect. Right? So this is how a data that is transferred, or that powers machine. So what is the impact? So we are just creating a factories that can able to think, that can able to learn, and it never sleeps. So that kind of impact a data science creates in terms of industrial data. Right? So the data that powers machine. So next comes the agriculture, the data that feeds the world. Right? So we are aware of the application scenario of agriculture, that we are keep on seeing all these information, like crop yield prediction on soil and satellite, through soil and satellite data. Right? So we are predicting the crop yield through soil and satellite data through IoT and satellite information. Right. So next, A-based pest detection using drone imagery. And so this an integral part where drone images are used to detect the pest. Uh, and there's a statistics from Microsoft ICRI SAT. So it is an advisory committee, uh, which is based on which is in Andhra Pradesh. So it has predicted that through data science or AI model, the rice yield percentage is increased to 15% in India. So this is the statistics from Microsoft and ICRA SAT A sowing advisory program. Right? So that is an important data. And the last point, which is important, that is water and fertilizer optimization. So these are the three integral part, where crop yield prediction through soil and satellite data, AI-based pest detection from drone imagery, and water and fertilizer optimization. So these are the three important applications with respect to agriculture. And so what is the impact? It is converting the smarter farming into a sustainable food system. So that is important. So the conversion, that is through the agriculture data. So this is how our data is transformed into a sustainable food system. Right? As I already told you, this graph illustration is from through AI model, which rice yields is increased by 15% in India, where they have taken data from soil, weather, and they have incorporated into an algorithm where the farmers receive real-time advisory through SMS alert. So these are all done through AI-driven forecast guiding sowing and fertilization. Right? So this is how a data is transferred from farming to sustainable food system. So the last part is important, the soil and environmental impact, where data for better planet. So yes, I already told you we are talking about climate change, we are talking about disaster response, and we are in the mix of social media, and all this has to be taken care. So you should have an separate data-driven framework in order to take care of all these uh, frameworks. Fine. So first one, climate forecasting and population modeling. That is important. Like data science plays an important role in terms of climate forecasting and population model. And second point, disaster response and resource allocation. Fine. So every drone or every uh, uh, autonomous vehicle is powered by a data science or a AI model where all the analytics and all the uh, navigations, all these are taken care of by a separate AI model, AI framework. So for this data, disaster response as well as resource allocation, you need AI, and which is an integral part to drive. And next one, social media analytics, which we are aware, where all the policies and well-being are developed through a specific data science. Fine. So this is important. So this case is taken from UNESCO, where data-driven forest fire predict system reduces loss by 30%. And so how it works? So AI model analyzes satellite images, weather data, and humidity level. So as per the statistics, it has reduced 30 percentage, and the model accuracy is around 88 to 92 percentage, which was tested on multiple fire data. Next, as I already told you, predictive alert issued upon 72 hours in advance. So this model as an alert system which alerts 72 hours in prior before a wildfire. So this framework is through data-driven fire forest prediction system, where it reduces 30 percentage compared to the previous system. So millions saved annual in fire fighting and resource allocation, where data meets nature, prevention becomes possible. So what is the impact? When data used responsibility, data science protects both people and the planet. So that word is very, very important. So you have to use the data responsibly. That is important. So if you use the data responsibility, it can be used to protect both people as well as the planet. Right. So this is data can be used for the betterment of our planet, which is a living ecosystem. Right. So this one, I just real time case scenarios. So which you can relate to. So this I've taken this from MVPI analysis, where we have analyzed. They have analyzed the Chris Gaines is a cricketer batting analysis, where data that powers sports. So they have evaluated Chris Gale's performance across key batting parameters. Like they have taken parameters such as hard hitting ability, finishing ability, fast scoring ability, running between the wickets, play consistency. So these are the five parameters that they have taken, and in these five parameters, as Chris Kyle is renownedly known for hard hitting ability, fast scoring ability, and play consistency. So these are the three. This three part is predominantly known. but is running between the wicket is lesser and finishing ability. These are the sample, or these are the parameters through which a data can be used as a resource to power a sport. These are some of the important aspects which we are using feature-based assessment. The model I highlight the strong score in hard hitting, fast scoring, and consistency, while showing low values in finishing and running between the wickets. So this analysis can impact player. It can compare performances, and it can also support predictive insights. So these are some of the examples where a data that can be used to power a sport. So this is these applications. As of now, we have seen 6 applications and their use cases. So now we'll be discussing on, as I already told you, specific use cases with data sets. Right. So we'll see 4 predominant use cases. The first one, Parkinson, Parkinson disease detection using voice data healthcare. Right. So ultimate objective is diagnosing a disease by listening to your voice. Right. So researchers, they have used UIC Parkinson voice data, where they've taken 3 parameters. They have taken vibration, pitch, jitter. These are the 3 parameters. They've used SVM machine learning model, through which the accuracy is around 90%, which I have mentioned here. Right. So what is the they've used UCI Parkinson voice data, where it is a repository. You're aware that the UCI machine learning repository is an Oxford University repository, where the data science, the data set descriptions are, they have around totally around 195 voice recordings, where 31 individuals participated, 23 are with Parkinson, and 8 healthy individuals. Each subjects were asked to pronounce a word, vowel sound R, through which they have captured the features such as frequency, amplitude, noise, nonlinear dynamics. So these are the features which they have captured, and the model, they came up with 90% of accuracy. So this is how Parkinson detection is attained through voice data. And so they've used only 3 parameters: vibration, pitch, and jitter. They've used SVM, and the accuracy is around 90%. And they've used these 4 parameters. So what is the application? So they have only used SVM. So we can the research can be focused on radon forest. So in order to improve the accuracy, and it can be furtherly used for biomedical signal processing, and for diagnosing and monitoring Parkinson progression. And so this is an important case study, and also interesting case study, because the voice data is used to detect Parkinson disease. So diagnosing a disease by listening to your voice. So next case study is Netflix recommendation engine, where Netflix, Amazon, and Hotstar, which plays a predominant role in today's entertainment factor, where your bingo habit decoded by algorithms, right? So as we are aware that Netflix has a huge data points. So the data points such as what kind of series, or what kind of sorry, so what kind of series or what kind of movies we watch. So it has a huge data points, and also where we skip, where we pause, and where we rewatch. So these are the data which Netflix has on each individual. So, through which a machine learning algorithm is used to recommend our daily movie recommendations. Even it can customize the thumbnail per user. Right? This is a huge impact where machine learning uses data science as a background, where it has a data point such as what we watched, what we skipped, what we paused, and what we rewatch. So these are some of the important data points where Netflix has. So, what is the impact? So 75% of all shows watched on Netflix comes from a recommendation. Fine. So, this is the data where 75% of all the shows which are watched on Netflix are from a recommendation. So, it has a complete detail of what we watch and what we skip and what we pause and rewatch. Fine. So, this is how the Netflix recommendation framework works. First, the data collection. So it has a complete view of our history. Fine. So it has the complete details of our interactions. So what we like, what we search, all these information Netflix has, and it has a metadata. So what kind of gender we watch. So what caste, uh, for example. So what kind of movie a predominant actor or predominant technician we watch. All these information are metadata which Netflix has. And time of day we watch and the device type. All these informations Netflix has. Viewing history, interaction like our likes and searches, the metadata which is general cast, and time of day and device type. All this information Netflix has. And through machine learning algorithms, it tests thousands of recommendation versions daily. Fine. So it uses neural network, it uses context-aware model, and also it uses collaborative filtering, through which it gives a personalized outcome. Fine. So as it is mentioned here, 75% of all the shows watched on Netflix comes from a recommendation. And so through the data which we have, the data points, like what you watch, what you skip, what you pause, and what you rewatch, a machine learning model is analyzes those information and it gives a personalized output. So 75% of all the shows watched on Netflix comes from a recommendation. Okay? The transformation of data into a tailored content suggestion. Next, G. We have already seen this, but I just want to elaborate this particular use case because it is important because it has lots of interesting aspect. Fine. So GE predictive maintenance, which I have already told you that GE uses thousands of data through which it analyzes and predict the maintenance aspect. Right. So what are all things which GE has? So GE has IoT sensors where it what kind of IoT sensors to monitor the temperature, vibration, and pressure. So these are the important and integral part for engine aspect. So the temperature, vibration, and pressure. Through all those data, the temperature data, the vibration data, and the pressure data, a real-time data framework, sorry, real-time framework, a AM model or a predictive analytic framework is being used. So through which they have attained reduced downtime. That is important. Fine. So what are all the categories? So temperature data. So temperature data. So what is the purpose? In order to detect overheating and efficiency loss, vibration data to identify imbalance and bearing work, pressure data to monitor performance degradation, fuel and flow data to optimize fuel efficiency, environmental data to adjust prediction for flight control, and these are some of the categories of data and their purposes. And so, as I already told you, the ultimate vision of GE Aviation is to have all these data in order to improve the maintenance aspects. So, as the tagline mentions, so it is fixing the plane before they break. So that is an important. Okay, so fine. They've taken all these information. So temperature, vibration, pressure through real-time analytics. They have improved the efficiency of the aircraft. And so this is important. The fixing plane before they break. And so they've used this analytics for the past. They have around 5 year data in order to improve the current flying mechanics. So the last and important aspect, which we are working on as of now, as ma'am already told, as we are part of an immersive reality and gaming framework where we are working on emotional adaptive virtual reality therapy, where we are using data science and XR, which adapts certain person's feelings. Right. So what is this? How it works? Right. So XR, you are aware that XR is where it combines your virtual reality and augmented reality. And so in this aspect, we have only taken virtual reality and how it works. Fine. So the data is captured through virtual reality headsets. Fine. So we are aware of Oculus, HoloLens. So you can use any of the virtual reality headset where the data is real-time data. For example, if you are using MetaQuest 3, you have an inbuilt sensor which can track your eyes. So you can track your blink rate, you can track the gaze direction. So that all those data can be tracked. So for example, so what's the purpose of those? So in order to detect the attention and engagement of certain persons. For example, if you are tracking a child's emotion or its feelings, so that information can be used like eye tracking, blink rate, and gaze direction. So additionally, you can use psychological sensors like EEG, HR, GSR. So what is the purpose? So in order to capture heart rate, in order to capture stress level, and also in order to capture skin conditions. Fine. So what is the purpose? So what is the ultimate objective? So in order to measure a certain individual's attention level and to provide a feasible methodology for them to have a relaxation aspect. Right? And also you can use voice data like tone, speech, emotions. So what is a process technique? You can use spectrogram analysis in order to classify stress and calmness. The fourth data point is motion control. So, what is the purpose? In order to capture body gesture, movement frequency. So, the processing technique is pattern recognition. So, what is the purpose? In order to detect anxiety or agitations. Right? So, how it works? So, all these informations, like which we have mentioned, the eye tracking, psychological sensors like sensors which are external sensors to calculate the heart rate, to calculate the stress level, to check the skin condition. All these external sensors are used, and along with that, we are using voice data to check the tone, to check the speech pattern, and to check the emotions in voice. Finally, the body gesture and movement frequency. All these data are captured in order to track the user's emotional state. And so all this information like blink, gaze direction, heart, stress, skin condition, tone, speech, face, emotion and voice, body gesture, and movement frequency. So through an AI model, AI analysis multimodal, all these data is fed into a AI framework through which the system automatically adjusts the user information. Fine. So what is the purpose? Where it is feasible? These applications where it can be used. For example, in terms of autistic kid, we are aware that autistic kid, uh, for them, attention is an attention. They lack attention, but they cannot concentrate in a particular scenario for a long period. So, in order to uh, use VR for that particular application, based on their emotions, we need to change the environment. For that, these data are feasible. So, through which we can analyze their blink, their gaze direction, their body gesture, their movement. So we can analyze so what they are looking for, and based on those data, we can analyze the user information. So these are all some of the applications. So this application can be predominantly used for, as I already told you, for ID kids, ADHD kids, where in abroad universities, in abroad research centers, where VR plays a important role. It is used as a therapy for all these kids. So so for that, data capturing plays a predominant role. You should have a mechanism or a data science mechanism to analyze those information and to give a insightful solution or a feasible solution. Right. So these are the important criteria. So this is the project which we are working on in our center, where we are in the 60% of the progress as of now. So I just want to emphasize this, and I just want to emphasize the role of data science through XR, which adapts individual feelings and it adjusts users' emotions. Right. So as of now, we have seen four use cases. One is Parkinson detection using voice data, which is an integral part for healthcare. Next one, the healthcare recommendation engine, where how the data is being used to transform to a personalized recommendation model. Next, GV aviation. So how the data is used for predictive maintenance, which is an integral part in Industry 4.0. And the final one, the emotional adaptive virtual therapy. That is important, where how a data is used to certain individual to have a separate environment based on their emotional aspects. Right, so as of now, we have seen all the applications relevant to data science, where I've concentrated on six major applications, and also we have seen all other four use cases and their data points. So now I just want to discuss about the emerging trends. So what is the future? So these are the important aspect like auto ML and low code AI. That is a major talk point uh, where data science plays a major role in that, and we are aware where Gen AI for next data insights. So the role of Gen AI, which is predominant, and where it's AI for IoT devices, where we are talking about autonomous drones, we are talking about agriculture drones, where edge analytics plays a major role. So, where the role of data science and AI is predominant in this aspect, where the application scenario is huge, wide, because edge AI is important because all the applications are drone driven as of now, autonomous. So the role of AGI is predominant in terms of IoT, and also explainable and ethical AI is the trends in data science and stuff now. Right. So as I'm particularly focused on XR, so the role of XR, data, and IoT convergence would be the future. So this XR can be virtual reality, augmented reality, or immersive reality. Right? So can be anything. So the role of digital twin, the convergence is a future is an emerging trends, or it is a future direction, the convergence. And so the low code AI is an important takeaway, and Gen AI, which is feasible for data insights. And I've also discussed about the edge AI, where which plays important role in drone analytics and ethical AI. So for all these, data science is predominant, and the convergence, the future direction, the digital twins which we are talking about. So finally, I just want to end up with key takeaways. Right. So data science impacts all the industries. That is important. So as I already discussed about Industry 4.0, where the impact of data science in terms of GE Aviations, where it transforms 5-year data into a 30 percentage of predictive maintenance. So that is how data plays a major role in terms of industrial aspect. Right. And second point, the real world data set empowers innovations. Right. So that we have seen in many aspects, like the VR therapy, that plays a major role, and the future, the integration aspect, the convergence, AI, ML, and XR. So that would be the future, because the the technology has a fast exposure, like XR, it can be used for any applications. So which is an upcoming feature, because it has lots of application scenarios in terms of healthcare, in terms of industrialization, in terms of Industry 4.0. So it has a vast number of applications where the role of data science convergence with XR would be the future. Right. So I just want to end up saying that data science is not about data; it is about discovery. So with this, I want to conclude my presentation. So I just want to thank Dr. B. Santosh Kumar sir for giving me this wonderful opportunity. And also, I just want to thank Anusha ma'am for coordinating this wonderful session. So with this, I just want to conclude my session. Thank you, everyone.
Thank you so much, sir, for delivering such an engaging and insightful session. As we come to the conclusion of our 6-day online faculty development program, it's my privilege and pleasure to deliver the vote of thanks on behalf of the organizing committee. First and foremost, I extend my heartfelt gratitude to our Honorable Chairman Sardar Gagandeep Singh Kohli for his constant guidance, encouragement, and visionary leadership that always inspire us to strive for excellence. My sincere thanks to our Managing Director, Dr. H.S. Saini, for his continuous motivation and unwavering support in organizing programs that enhance the knowledge and skills of our faculty members. I also express my deep gratitude to Dr. Sanjeev Srivatsava, Director of GNIT, for his valuable guidance and continuous support throughout this FDP. A special note of appreciation to Dr. K. Venkatrao, Principal of GNIT, for his encouragement, constant support, and for providing us with all the facilities to conduct this program successfully. My sincere thanks to Dr. S.P. Yadav, Academic Dean of GNIT, for his constant cooperation and motivation in all our academic endeavors. I would also express my heartfelt thanks to Dr. B. Santosh Kumar, Head of the Department of Computer Science and Engineering, for his constant encouragement, valuable suggestions, and continuous support in organizing this FDP. A big thank you to all our resource sponsors, eminent academicians and researchers who took time out of their busy schedules to share their valuable insights and knowledge over the past 6 days. My sincere appreciation to the FDP coordinators for their excellent planning and smooth organization of this program, ensuring its grand success. I also extend my warm thanks to all the faculty members who contributed to the smooth conduct of each test session. Last but not least, I sincerely thank all the participants for your active involvement, enthusiasm, and cooperation through this faculty development program. Your participation made this event truly meaningful and successful. Once again, thank you all for being a part of this FDP and making it a memorable learning experience. Thank you and have a wonderful evening.